So hello everyone. Hello, thanks for coming today. Welcome back to another night of Global Hack Week, Web3. So yesterday we were learning how to use Smart Pi for creating smart contracts, and today we're going to continue that. But first, let's just give 5 minutes to learn a little bit about the Student Developer Pack. So let me just search the Student Developer Pack. Okay, so welcome everyone. Hi to everyone who's connected. Thank you so much for being here. Let me just share my screen into the GitHub Student Developer Pack the slides. And yeah, now I think now you can see the page. So yeah, so as you know, if you're new here in the stream, so we spend like 5 minutes to talk a little bit about the student developer pack from GitHub. So GitHub Education gives you for just being a student a pack that basically is a digital toolbox that gives you tools and experiences for you for learning new things into the web into the tech industry. And yeah, so you have a lot of experiences that you can interact with. So if you want to build a hackathon in the cloud, if you want to I don't know, build your first portfolio, if you want to build a mobile application, data science and machine learning paid app or anything like that, you have a lot of experiences that help you to understand which path you need to use for learning some of these things. So give you so GitHub gives to you a lot of tools that you can use for free when they cost like the 100 or like 50 USD or anything like that. So yeah, so you have a lot of tools that you can use here, and those are the experiences. The other thing that you receive as a student for free is a lot of resources for free and IDEs. So if you want to make your first portfolio, if you want to host your web page, you have Namecheap, you have Name.com, take domains. If you want to use, I don't know, server and the cloud, you can use DigitalOcean, you can use Microsoft Azure. Like you can use a lot of things here, and you can use them as you want. Say, for example, if you want to host with your friends a Minecraft server, you can use DigitalOcean for hosting that server in Minecraft. So if you don't want to, you can use, I don't know, Microsoft Azure also gives you free access. So a lot of cloud services and gives to you like almost 3,000 credits. Digital earnings, like with all the tools that you can use here with the student developer pack. So for example, the JetBrains IDE is like really expensive, all the IDEs. So if you want to save a little bit of money, you can use them for free for just being a student. So if you want to host an API, you can use Heroku. If you want to learn a little bit more about your career readiness, you can use Educative for learning a little bit more about algorithms, concepts, and things like that. If you want to learn machine learning or data science, you can use DataCamp. If not, you can use Frontend Master for learning a little bit more about front-end technologies. Also, you can use Bootstrap Studio for building your first web page or web application with just a drag and drop platform that you can use. And also, uh, you can use MongoDB for just hosting your new database, or I don't know, you can use Algo Expert for training a little bit more for your next technical interview. So yeah, that is the student developer pack. And another thing that you can use is the GitHub Code Spaces. But for getting your student developer pack, you should go first with individuals, get student benefits, and after getting your student benefits, well, you can just send your school ID, or if you have anything like um, I don't know, if you want anything like um, if you have something like a document that has your grades, or if you had like an educational email, you can use them also for just claiming your student developer pack for free, and it takes like 3 days in claiming it. Yeah, so that is how you get the student developer pack. And another cool thing that you get is the GitHub Code Spaces. That GitHub Code Spaces basically is Visual Studio Code on the cloud. But the cool thing about this is that you won't spend any kind of resources from your computer, whether it's hardware or like your CPU, RAM, or storage. everything is going to be stored in the cloud, in the GitHub code spaces, and you can easily integrate a lot of extensions, themes, your favorite fonts or anything that you like. So you can use Jupyter notebooks. You can use Visual Studio Code like JetBrains. You can also use your terminal and inside terminal in your browser. So that is really cool. So you have almost like I think the lowest tier is from 2 core with 4 gigabytes of RAM. So that is a lot of stuff if you want to host anything. So yeah, I think this is really cool, and this is one of the cool things that GitHub gives to you for just being a student. So you have like almost 60 hours for free for just being a student. So yeah. And now after we got that information, let's try to continue with where we started. So I think now you can see the page. Cool. So let me know if you already see this. So yesterday we were investigating a little bit more about SmartPy. Basically, SmartPy uh, is a solution that allows you to create smart contracts with Python and cannot support a type system, but with Python, so you can define kind of types like integers, tuples, timestamps, lambdas, operations, and things like that inside Python, being like a smart type, a smart type it. So yeah, it is real cool. You can use it. This tool uses Tesla's blockchain, so yeah, you can use it for these kind of integrations. So yesterday we were kind of introducing ourselves to SmartPy. So we learned new things like how to use the models of SmartPy, how to use tests. That basically tests are things that SmartPy does for running some kind of tests. The last test that we ran yesterday was to create a transaction in bots. So we were building something like this. So we have a user, we have a bot, and we have an options. So basically, options, the start is just like an array. I think you can see it right here. So basically, we pass options. So imagine that we are having I don't know, vote or poll or anything like that. So we have option A, B, and C. And I don't know, what if I want to track like for each user that I have, I want to track like which user voted for which options, and I want to track that operation and or that transaction in this blockchain, so I can use it for a while, right? So yeah, I have my options map. Then I kind of convert this list into a dictionary in Python, but dictionaries are maps in SmartPy. So it is called sp.map, and we iterate for each option in the options array, and we add a zero key to each of the options. So A will start with zero, B with zero, and C with zero. Then we print the options. Then we create a new voting contract that the voting contract receives an options map, and then we say something like, hey, just start a new option variable with the value of the options uh, with the options parameter that I passed to you. So I think this shouldn't be like this. So this should be like options map or anything like that. So we don't confuse with each other. So options map, yeah. So let me see if this works. Yeah, it works. So yeah, we say, hey, initialize an options map, and it's going to have the value of the options parameter that you pass me. And so yeah, then we create a scenario that basically a test scenario is going to create, or well, it's going to run our model that we have here, that is main, and then we're going to initialize our test. So basically, our test is going to appear like an Markdown or HTML H1, and then we're going to add to our scenario all the kind of tests that we have. So the first thing that we do is the operation of just starting everything, and then we create a vote to A. But also, if I want, I can create a vote to B. So let me do that. So let me create that to B and C, and let's see if this changes. So yeah, as you can see, we can interact and try to see each one of the boats that we have. So we have boat A. So we have first A as it is. Then we have A and B voted, and then finally we have A, B, C, A, B, and C. But the cool thing about this is that we can interact or like check each one of the transactions that we can use. So for governance and use of this, like mutations or political things, this kind of works, or like it's a great tool for tracking secure data for each one of the individuals that are going to make a votation for each one of the candidates or their options, right? Also, if we have a poll, we can also do that. So the thing that I wanted to do now is to try to start this and kind of understand a little bit more about how we can use the things that we have already built, but within an API. Like what I want to use is like having an API, and this API is going to have something like API is going to be the how can I say this? Is going to be the mediator within our something like an application, a web application, mobile application, or whatever you want to do with our blockchain data, right? So the blockchain smart contract that we have here. So we should have something like a smart contract, and also we have something like our web application, right? So let me just write this smart contract and application to do a web application, and I think with that should work. So then we can do something like this, and then just having something a little bit bigger, like this. And yeah, now you can see my um now you can see like the thing that I'm talking about. So yeah, what I want to do is to have a web application and then have like a poll of A versus B or anything like that. So maybe I have something like I don't know, A, and the option two is something like B. So I want to have a kind of interaction. So for each time that the user votes for the option A, the API stores in our smart contract the transaction of making that vote, and then pass to our API the result of that transaction, of the log of that transaction. The API is going to store it. Maybe we can store it in something like a database. So we should have something like a DB database, and then we can pass to the like that log to our web application. So like I don't know, to a dashboard or anything like that. Like, hey, user one made a vote for the option A, or anything like that that can help us to create that. So let's try to ask our real friend ChatGPT. Okay, so let's try to ask ChatGPT here. I created a smart contract in SmartPy in the blockchain in the how it was called Tezos, in the Tezos blockchain. Is there any way I can use an API for each time that a user interact with my page to make a transaction voting? So I think I should recreate this prompt, but let me first copy and paste this. So, okay, so, so I'm using the version, latest version of the SmartPy, and I have a web application for votings. I want to make a code, an API that can interact with my smart contract to each time that the user makes a vote for some option, the API calls the smart contract to make the vote for that option, and then what? And then return to the API the log of that transaction. Then the API returns that log to the web page, the app. So let's try. So let's try to say that this is my smart contract. This is my smart contract. Okay, so let's see what ChatGPT says. So to ship your objective engineering with the smart contract using an API, you'll need to set up a backend services, for instance, Flask or Express.js, that will interact with the Tesos network using some Tesos client libraries like PyTesos, or for Python, or Taquito for Java. Taquito. So let me search that. Taquito JavaScript. It is real. Taquito, the both and Tesos can be delicious. Who made this? Use our popular Taquito TypeScript library to develop your Tesos blockchain apps faster and easier. Cool. Looking for a simple way to work with Tesos? Wow, this is so cool. Awesome. So let me see the repo so I can start it. This is so cool. And yeah, so let's continue with this. So that is a cool name. Okay, so it says that we should interact with the Tesos network using Tesos client libraries like PyTesos for Python or Taquito for JavaScript. Here's a simplified breakdown of the steps. So set up a backend server. So for ticket simplicity, let's assume that you use Flask for Python. Implement the endpoint for voting. So here we will use the PyTesos library to interact with your smart contract on the Tesos network, then get the transaction log. After interacting with the smart contract, you can fetch transaction logs. So return the transaction log from it. Here's a simple code so you can set up such an API. So we can import first Flask for import front has JSON file. So then we import Tesos. Then we have our Flask application, contract address, okay, the keypad, network, Tesos is equal to Python using aha. Then request data.json, option data get option, if not option, return JSON file error aha. Contract Tesos, contract aha, address aha, hash aha, okay. So then call the API from your front end, whatever you use to submit as a vote in your web app, you can make an Ajax to the call boats endpoint with the endpoint as a payload. Once you get the response, you can display the transaction hash now hash unlocked to the user. Always keep your private key secure. Haha. Okay. So let me ask, should I modify, or like, how can I deploy the smart contract that I showed you in the Tesos blockchain? So applying a smart contract to the Tesla's blockchain involves compiling the contract, estimating its start and gas, and finally sending a deployment operation to the Tesla's network using the PyTesla's library in Python. So first we use compile, deploy the smart contract. Okay. So first you need to install the required libraries, then your smart contract with the written smart is written in SmartPy, so it must be translated into Michelson, the language that Tesla's nodes understand. However, as for oh, okay. So should we do that? Hmm. All right. So first, let me Google that. So SmartPy deploy or migrate to Tesos. Okay. So we have a tutorial. Okay. So we have. Mm-hmm. Okay. So there's this explain the smooth contracts in SmartPy. Mm-hmm. Okay. 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 Right. 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 Okay, so now that you're familiar with the basics, let's write a slightly more interesting contract. In this part, we're going to make a new currency, which we call the ducat. So the contract, so a common way to implement a new currency is by using a smart contract that remembers the number of tokens, here ducats, owned by each participant. This is akin to a bank maintaining balances number of ducats for current accounts. So to start, we'll create a model with a contract. So here explains tokens. Uh-huh. So we have then if this is scenario. So again, this is explained in tokens for the resources. Okay, friendly place ask questions, smart by manual. So we have overview, glossary, examples, entry points, policies, token metadata, examples. Okay. Mm-hmm. Okay, so we have open source. Okay, so we have a smart pie. So this model explains a little bit more about. Oh wow! It compiles into Python and then OCaml and oh, this is cool. So actually, it is compiled to OCaml and then to Michelson, and then the tests are compiled to an HTML report. Okay, this is cool. Because so once built, the smart Pi contracts become smart ML contracts, and then they're handled on OCaml library called the Smart Engine. And then what? Hmm. Okay, so it defines a smart contract. So then the storage, then the entry points. Uh-huh. So then the installation. Uh-huh. Mm-hmm. Mm-hmm. So this is what we try to do. So then we have a smart contract. Settings. And then we have Explorer Wallet. Settings. All right. So I'm trying to check. Um, I'm trying to check if there's any way that we can download that contract or like pass it to other part. So about the Smart Pi, So then, so about the raffle contract. So raffle is a game exchange distribute winning prizes. The organizer is charge of defining jackpot selling tickets. Hmm. So here's making an example of that raffle. Then the storage definition. Okay, okay, okay. Then the test scenario. Hmm. Mm-hmm. All right. So blah blah to stop in the hand by keeping so then this keeps explaining the references. Okay, so then we have an introduction to why to Tesos. So I think this is the same thing that we have. Okay, so we have Tesos basics, blockchain basics, proof of work, introduction nodes, liquid of proof, CLI. So then we have introduction to Tesos, but what? So so we have an important node. Okay, so let me ask ChatGPT. So is Tesos so by changing the smart pi into contract into a what? It was called. It was called. Um, Let me see again to the documentation, so we can see the installation here. To Michelson, it's called. To Michelson. But wait, like here says that the smart contract automatically is compiled into a Microsoft contract, so we don't need to compile anything. All right, so SmartPy offers an alternative. It's a smart contract library. It comes with numerous tools in the form of SmartPy IO. Okay, let me see what is this. Smart contracts and Teslas, a comprehensive solution for developing, testing, and deploying smart contracts into the blockchain. So then how we can deploy? So we have a tutorial, but I want to know how we can deploy a deployment. So, hmm, so deployment, meant function like to language for the deployment. Okay, so so before deployment, contracts can be tested. Once ready, SmartPy can just compile to Microsoft. The test is blockchain native language for development, for deployment. Sorry. So the Smart Pi Online ID offers a user-friendly interface for trying out the system directly in a web browser. It comes with an origination feature for deployment of contracts to the blockchain at the click of a button. For those who prefer wired smart contracts and test in their favorite editor or command line interface, Smart Pi Explorer, which allows this exploration and interaction with already deployed contracts. So it presents contract data as smart pi values such as records and variants. So with the smart pi, the possibilities for creating and deploying smart contracts on the Tesla blockchain are endless. So deploy, let me search if there is another option here so we can use them. Use the smart pi online ID for well, I don't see anything. So then can we do something else? So we have tools, contract from this, this to panel, coding link, configuration. Then we have the editor, the explorer. So we have another contract address, and then so should we search in other part like this? So we have the syntax, the test scenarios, contract simulating targets, and well, we don't have that. Then we have cryptography. Um, well, I don't want this. So we have the test example and the types. Then what can we do? So we have operations, then we have news. This has a little closet discussion forum. Starting the Rails is Smart Pi. Okay. So let's see in the discussion forum if we have something. That's what I'm trying to search because I don't find anything that is related to that. So do you need? So hello Indigo. Hi. Thanks for coming here. Okay. So getting started. Notice part. Start your journey here. Development tokens. So let's try to see here. Split count the multiple models, cutting contracts, created with create contract, checking and modify a record that was initialized is known, passing variables to create a contract, that's send it in. All right. So then use syntax contract deployment using Smart Pi without Docker, how to receive testing and entry point. Okay, so this is like interesting. So if you're using ID, you can just add run to the transaction. Okay, right. Cool. So yeah, it says that we can run transactions without the needing. Well, we can do it if we want to. So we don't. So for running things or making tests, we don't need any kind of transactions. And I think if we configure this for not making any kind of transaction, that should be okay. So let me change the for to the dark then, so you don't burn your eyes while you're watching this. And blah 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 blah. Okay, so let's once again try to install the CLI in our machines. So blah, 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 blah. Let me go again and CLI here. CLI in home guides, libs, overview. Okay, so let me go into the installation. And for this, wget smart IO, smart pi. So the preferred way of running smart pi via a wrapper. Okay, so I think I saw something here in the forum that says running smart pi without Docker. Okay, so hello, I use smart pi legacy using directly smart pi environment and files. I saw that the new version of SmartPy is solely installable using Docker. However, I am using Micro M1, which prevents me from using Docker server properly. Is there a way to use the environment to new version SmartPy? Uh, so basically, if you want to install SmartPy together, you should run Docker container. However, if there is no way installing Docker server, uh, uh-huh. Okay, so should we install first Docker in our code space? So let me see that. Let me go into the code space I had here. Okay, so then we should use first Docker. So is this in the Docker compose, or I think I need a little bit more of explanation of this. Because it says the preferred way of you running SmartPy is via the SmartPy wrapper. This requires Docker and works in both Linux and macOS. It can be obtained as follows. To test it, you can download an example of the run. So this requires Docker. So this is Docker Desktop. So Docker Desktop on Linux runs a virtual machine VM to create, so uses custom Docker context. Okay, so let's see how to install that. How install SmartPy in Docker. So, okay, so there's a Docker file here that allows us to do that. Okay, so we have Truffle Suite, SmartPy Basic, Python library. Okay. Right. So let's go here into the into our code space that we had here. So we startly used a virtual environment of Python, but I think we don't need that anymore. So let me just first start a new file called Docker file, and then initialize this Docker file here. So yeah, let's install just Docker here in our extensions. So, okay, so we have Docker file. So from Alpine, run apk add node.js bash, cool Python, then run bin bash, All right. So now let's ask ChatGPT how we can run a Docker file. So how can I run a Docker file in Linux? To run a Docker file in Linux, you first need to build an image from it and then run a container using that image. Here's a step-by-step guide. So first we need to install Docker. So okay, so then start Docker and enable added boot. Build in Docker. So So navigate at the directory containing your Docker file, and then sudo docker build my image. Okay, so then first let me ask, is there command that I can use to ensure I have Docker installed? So yes, you can have, okay, yeah, so let's just run Docker version and then use something like that. So Docker um, version. So yeah, we have Docker, awesome. And then for running it, we should do sudo apt, no, sudo docker sudo docker run my image. Okay, so then let's go into our code space and then run sudo docker run uh, my image, but it's if I want just the Docker file, uh-huh. Okay, so we have the Docker file, then build the Docker image. So should I use just sudo docker build and dot so sudo docker build dot and that's it. Okay, so what does this say? It says building finish, internal load docker ignore, transferring context, load build definition docker file, transfer failed to solve, failed to read docker file, open docker's not such file directory. So where are we? So then let's see how to run to build a Docker file. Okay, so we have here Docker build. So we Git repository. So we have Docker build the Git repository, the text files. Instead of specifying the context, you can pass a single Docker file in the URL or pipe in the file via stdoin. Stdoin to pipe Docker file from So with PowerShell, which you can run get context Docker build. Hmm. Okay, so building Docker images with Docker files. So, create a file. Okay, then, here's some commands. No, I don't want the enterprise version of that. So building a testing Docker fast fiddle or good with Plugin Docker and start a new session, you need to create account first once you have a new instance. Then next create edit direct Docker file run. Docker build and then that. Okay, so let's go here then, and then Docker build. So do I don't have anything here? So let's see. So what can we do with this? Okay, so we have Docker, Open Editor, Expose Board. Oh, okay, so we can just click in that. Build image. Okay, so let me see again. So we have a Docker file, then here's editing it. Then it builds the image. So then if we build it like this, so are we forgetting to do something here in the Docker image? Socialite gets restart he did because I think the editor is not getting like the Docker syntax, or do we need something like other Docker formatter or anything like that? So we have Docker linter, yeah. So lint Perl installation. Okay. Wow. I don't know what is going on with this. So let's just call BNB so we don't get all those changes. And then go again here into our code space and see the Docker hub. So filter with Docker file. So let's ask then ChatGPT what are we doing wrong. So will this Docker file get an error? And if I have it on my root, how can I run it? So your Docker file intends to create an image. Let's bring that. So from Alpine, this sets the base image to Alpine Linux. Then this installs Node.js. So the next run commands are intended to install SmartPy CLI. So however, the sequence to install SmartPy using curl could potentially fail because of the Alpine image might not have the necessary CS certificates to make HTTPS request. So to ensure it works, you might need to install curl without CS certifications. Just add security to the cooler. Okay. So just add. So you might just add to the curl to bypass the certificate checks. Okay. So then we need to go. Okay. So no, I don't want to do that. So The name of my image is a Docker file. Should I pass just um, Docker file? Now the name of the Docker image isn't determined by the Docker file. Instead of the image name, whatever you specify when you build the image using, okay, so yeah, I got it. So we name the image. Then you will run it using, okay, got it. Got it. Okay. So we instance uh-huh. So when David says you can deploy the contract from the SmartPy web interface, so you run the code, there's an option that says deploy microsync contract. Then you will need a wallet and some testnet tokens as you want it. So I had experience with Remix and Solidity, and it's kind of similar. Oh, thank you so much. Will okay. So you mean that we should go like into our SmartPy ID and then deploy it with the option of Michelson, or I didn't read you well. So you said you can deploy the contract from the SmartPy web interface. After you run the code, there's an option that says deploy Michelson contract. Okay. So okay, then close. So then all right, deploy my consume. Yeah, you're right. So we have the deploy my consume contract here. So we had a summer, Michael June. Okay, so we have here direct network contract originations, so node and network. Build node nano wallets, select account, and select the ledger, the account, the secret key. Oh, got it. So we need the store account, then manage your accounts. Okay, so let me manage my account here. So I should just add an account and generate and create this account. Then open it and then copy this. Then let me just restore this. Then David. Okay, so then validate. So mounting test. So then we have a deploy contract. Parameters, parameter byte encoding, then accept it. And so sizes is storage code, my console code, storage JSON, encode JSON. All right, so we have this. Right, so let's originate from browser. SmartPy nodes and view node data. Context error checkpoint. Got it. So then we have the wallet, then we have the account wallet, revolve account originator parameters, delegate amount in test, SQL codes from receipt, starts limit, So this happens because I don't have any kind of Tesla's fee. I don't have any tokens in Teslas, right? Smart by cool. You have to change it from maintain. Okay, to GhostNet. So can you? Okay, let me. I want to know what is GhostNet and what is MineNet. So let me just run. Okay, so let me go here and ask ChatGPT. Um, what is GhostNet and what is mainnet? To be honest, I don't know what is that. So since the confusion question, GhostNet doesn't correspond to major term technology, cryptocurrency spaces, a lot of you might be thinking. This means with real transactions of a blockchain take place when a new cryptocurrency is being okay. So let me let's search here. GhostNet versus mainnet. Uh, or how it was called? It was called um, GhostNet, Smart Pi GhostNet, Smart Pi GhostNet, and okay, so this is the public nodes that have. So have a mainnet that's Smart Pi. So are they just endpoints? Block label GhostNet Smart Pi.io. So RPC. Okay. So then let me go again into the. I think I open a Tesla here. So let me just search something like notes. Yeah, here it is. It says nodes. A blockchain is a peer-to-peer network in which every peer is a node, ensuring a set of diverse functions within the distributed software. In this chapter, we will explore the notion of nodes in Tezos, focusing on their roles, features, and limitation. So, a node is a machine that stores a copy of current state of the blockchain and updates it with the information it receives for other nodes. Okay, so therefore, a node is connected in a peer-to-peer way to plenty of other nodes. So a node systematically communicates information it receives to nodes to it is connected to in order to later on allow them to transmit this information to their own peers. So this ensures that every node from Tesla's network stores the same information. So the particular of public blockchains lies in the fact that anyone can launch a node. The chain is therefore expected to have a large number of nodes, thus reducing the risk associated with the potential failure of an important actor of the network. So once launched, a node connects itself to other peers in the network, establishing communication channels and thus allowing the interested parties to share information. Okay, so we have when launching Teslas and now several configurations allow to synchronize with our peers of the network. Okay, full mode, running mode. So now the chips. Uh-huh. Oh, okay, so the test net is called GhostNet. Yeah, for testing. And the mainnet, when all the transactions are made, is the mainnet. Okay, okay, yeah, got it. So then we have the configurations, snapshots, possible actions, information storage, transmit, transition, communicating advantages of using node, possible node attacks. Okay, awesome. So then we were, I think we were here. Okay. So then I want the GhostNet, view node data. Okay. So then we have loaded already an account, and then we kind of push to this contract, and nope. So then what is going on with this? So we have the storage, share organization. So please choose a node on Tesla network, assigner, and some originator parameters to originate the contract. So we have originator pressure, so such as delegate. Okay. Sufficient test 0. Implicit empty implicit contract. So it says that the contract is empty. Parameters and script bytes encoded. Branch photo, implicit empty implicit contract. Okay. So we have a simple example, well, my example with a simple storage and all is more entry point. Store value, calculator, FIFO, contracts, inheritance, Fibonacci view, minimal contract storing, user defined store first time. So simple FIFO, no, did I did something? No. So okay, so we were reading, I don't want to read this, I wanted to read the template of the simple template. So yeah, it stores the parameters, the welcome, the contract, and yeah. But does he have anything to verify if final storage? So my entry brought it valid fail. It has scenario. Okay. So then we have like this. Okay, in the what section there's a link where you can claim test. No, okay, testnet no kit. Okay. So let me go to that. So I have the wallet section. That's a different folder. Then let me go to my wallet, and then me T-shirts, interact operations, account information. Mainnet, SmartPy, Gasnet. Here to the faucet, Gasnet, connect wallet. So to ensure the phase distribution, request. Okay, got it. So I have my wallet here, view. Okay, so then let me create it. So it says I need to create a wallet here on Kukai. So let me accept that, and then let me try to change this. So just give me a minute until I create my wallet in the testnet. Okay, so just let me finish this and created my wallet on Kukai. All right, so I already have this, and then I can say Kukai. Okay, so is it already connected? Yeah, it is already connected. Okay, so it says that I can get just more wallets, more Teslas. So didn't I connected it? Let me just reload this. Then connect wallet, then Kukai. Awaiting confirmation on Kukai wallet. So do I need to connect? Okay, so connect. And then copy address, settings. So I have my. Okay, so yeah. So request just 100 Teslas. So then it sent me to other part, I think. Let me go here into my QK and just update here. Okay, so I have now the 100 Teslas. So yeah, already. So I already have the Teslas. Then let me go again here into my account. Let me reload the page. And then I wanted to deploy it on GhostNet. And then I want to select my account, David. I don't know why it says I don't have any GhostNet Tesos. So I already passed to my wallet. Okay, yeah. So I already have my 100 Tesos. So then share for distribution, work challenge. Okay. Okay. So then what? Then should I just go here and then you can find any addresses. You can find the address you have in the smartphone. Okay. Okay. So with the address, you mean the one that I had? Transaction, Michelson. Copy storage transaction. Zero. So with the address, you mean which kind of address? It says you can find any address also. You can find the address you have in the Smart Buy directly. Okay, so you mean this address, like the one that I have right here, or which address do you mean? Uh, create contract, the contract, let's start contract. But the cool thing, Okay, so let me continue getting more Tesla. As I have my GhostNet here. Okay, so I was on QK and I wanted to get more Teslas by the faucet. Found any address, wallet address. Oh, I got it. Like, you mean the address that I have on my account? Yeah, I got it. Okay, so then I go to my wallet again. And where's my wallet? Here it is. Then, yeah, now I have my 100 Teslas. Yeah, sorry for that. I didn't kind of understand which address you mean, but it's the wallet address, the wallet like ID that you have here, right? Got it. So then let me again reload the page. Choose a node in Tezos network. Then I want to create a GhostNet node. Then select again my storage here with David. Then validate. Then reiteration. Fixing that. So then deploy contract. And then let's go and rebuild key. Proton arrow that contract and rebuild key. So which key it means? Uh, bytes and codes. Okay, so with the rebuild key, I mean uh, hashes, hash, accept, what is the rebuild key then? So the originator pile, the reveal account. Also, the key is the reveal, the reveal account. So let me just rebuild the account then. Okay, so I think now it's rebuilt. So then let me deploy it. All right, yeah. Okay, got it. So then set contract. So this is the bold contract, loading contract. And we can add the contract here. Okay, yay, we have already the contract address. Right. So, okay. So now the question is, what do we do with this? Because we have the voting contract and we have, what is this? What is better called that? Better called that. This is like a code name. So nothing found. And then explore with the smart pie. Ghostnet, 44. So then explore contract. Interesting. So once, all right, so it is deployed on the node on the ghost. So it is rebuilt on the ghost nodes, but on the ghost net, I mean, but for some reason I cannot see it in the ghost node in the ghost net. And I don't know why. So let me go to the Node Explorer. So blocks help, block. Mainnet. No, I want the GhostNet nodes. And I want these four. Oh, but this is the block hash. Oh yeah, but actually it founds it. Okay, you may have entry points. No. So I have my data. So did we just deploy an empty contract without entry points? Okay, once Evolution is good, Hungry Nation. Okay. So maybe we did just deploy the empty contract. So let's go here. Then go into. Okay, so let's run this again. So transactions are okay. Okay, then deploy Michelson contract. Generated Michelson, size is copy. Summary, Michelson transaction. So then we have a summary that says both, yeah. And then deploy Michelson contract. So delegate and then. So my question here is, if I enter like in if I enter for like in a private browser, will it recognize that? Shall I introduce anything? Because I don't know like if there is something that I should pass here. So yeah, I think that I need to pass something so the account knows, or like it knows which kind of contracts I want to pass, because it just takes me into the storage. So code JSON, storage, code. Okay, so then copy this. Yeah, so I think I should go here, select my wallet again, debit, then reveal account, then reveal account. No. So then deploy the contract. Nope. Nope, 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 nope. The storage. They have something. Okay, so it actually passes the storage. I have my storage JSON and I have my code JSON. And then the code I also have it. Hmm. Interesting. Okay, so then I can deploy the contract like this. Empty implicit contract. Oh, I think it's because I lost the 100 pesos. So I need to go again into the pesos and request again 100. Okay, okay, so let me just again request more pesos. So let me select the models. No, motorcycles. Next, and verify. Okay, so now it's going to solve all these challenges. And I hope to get the 2000 pesos, but I think it's going to take a little bit more of time. So Will David says, not sure, it's my first time applying to Tesos. Yeah, it is weird. It is really, really weird. Okay, so yeah, I think I got it right now. So let me go here again and then go again here. Okay, already built account contract. So let me go into the GhostNet. Oh, I think I got it. Where? Blah, blah, no data. No data. No, it was. I needed to go here. But then if I open a new browser and just share a normal tab, or like, okay, so I tried to go into the route here. So I can imagine that it kind of stores something when you run the contract in like your local storage, like the values that you already passed as a JSON, or I don't know, to be honest. But like as you see here, like we access it in a private browser, private mode, so it doesn't find anything. But if we start here, and I think I just closed my window, yeah. I think it was this one. Yeah, but if we go again and restart, restart, refresh, 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 like we are going to still have the contract that we had from our IDE. Okay, so then let's go into the GhostNet. Select another account, then David, then validate, then deploy the contract, then accept it, then open Explorer. Huh. In known networks or explicit RPC. Huh. Interesting. So ghostnet.smartpi.io 404. So is the server like down or anything like that? Huh. So this is our node RPC. And let me go in here. Contract. Nope. Neither. So we have block confirmations, then zip contract. Part three. Second try, maybe. Then add the contract. Then we do second try. Nope. I have no idea what is going on. Because we did store something, but we are not finding anything. And yeah. Yeah, it is weird. Yeah, actually, it is weird. Hmm. So I think we should. Uh, well, we can spend time trying to find a solution, but I don't know if this is the optimal way of doing things. So let's try if we have another alternative for finding, for creating smart contracts. So what do you think if we look into that? So create smart contracts in Python. So we have a complete guide. So it's also with Solidity. No. So we have Web3, so I'll run the following command source on the .NET.mb. I'll get Solidity smart contracts to deploy in Python. Okay, so it uses kind of similar to what we were doing with Truffle and also with Solidity, because it uses Ganache for performing the operations in the machine. On Python complete guide, import necessary libraries. We need ETH, how we treat, Solidity, .mb, and read the smart contract in Python. Uh, okay, so actually it's just for deploying the smart contract in Python. It's not for writing the smart contract. Yeah, it gives us our ABI. Yeah. Okay. Interesting. So there's another part that we can use. Let me search for another solution. So have you used? Um, yeah, one of the options that ChatGPT gave to us was Viper. Yesterday we tried it, but I think we had some problems with the CLI. Well, maybe it takes a little bit more time. Okay, so then what can we do with this? Okay, so did you suggest Will to get a? Let me just close everything here. And we're going to listen to Will and try to use Viper instead for writing smart contracts in Python. So instead of this, let's try to search Viper Python. And Pythonic is smart contract language. Okay, so does he have any kind of documentation? Nope. Okay, so we have Viper then. Seed installed Viper, yeah. See tools and resources support, then learn how. Okay, again is with Docker. So take a deep breath, follow the instructions, and please create an issue if you encounter any errors. Okay, so I also have beep. Okay. Viper can be downloaded as a Docker image from Docker Hub. To run the compiler, use Docker run, and then ultimately you can log into Docker image. The normal parameters is supported. And also we can use pip. Viper can all be built using Python, so creating a virtual environment. So that new packages install dependencies build extremely in native Viper with no alter effect. So installing Viper, pip install Viper, then what Viper version. So we can also use Nix for installing it. Okay, so let's try to use pip in our code space. So let me just reload again the code space so we can see anything. So my hair is a mess today. I have to get a fresh cut tomorrow. Okay, so let's go here. Again, let's just run pip install Viper. After installing it, says that we use pip install Viper, Viper version. Then clear Viper version and 0.3.9. And after doing that, let me return again into the repo. So it says tool resources for additional list of framework and tools Viper support, documentation overall. So to compile a contract, use Viper ufl.py, generate bytecode, testing using PyTest, and then contribute. So we have Viper here. So Viper is a contract-oriented Pythonic programming language that targets the Ethereum virtual machine. So principles and goals. The principles are security, should be possible and natural to build secure smart contracts in Viper. The language and compile simplicity. The language and compile implementation should strive to be simple. Then auditability. Viper code should be maximally human readable. Furthermore, it should be maximally difficult to write misleading code. Simplicity for the reader is more important than simplicity for the writer. And simplicity for readers with low prior experience with Viper and low prior experience with programming in general, it's particularly important. So because of this, Viper provides the following features: bound and overflow checking and array access are arithmetic, support for signed integers and decimal fixed point numbers, digitability, strong typing, yeah, and small understandable compiled code, and limited support for pure functions. Okay, got it. So then installing Viper, then next, what is the next one? Viper example. Okay, so simple open auction. So an introduction example of smart contract included in Viper will begin with a simple open auction contract. As we dive into the code, it is important to remember that Viper syntax is valid Python 3 syntax. However, not all 3 Python functionality is available in Viper. In this contract, we'll be looking at simple open auction contract where participants can submit bids during a limited time period. So when the auction period ends, a predetermined beneficiary will receive the amount of highest bid. Okay, so first we start something with this. Okay, so Okay. So can you give me a little introduction to Viper in Python? So again, let me see if we can do it a little bit faster with ChatGPT. Development language aims to be music readable, solidity, dominant language Ethereum, haha. Language Ethereum is more contributed web solidity is heavily influenced by JavaScript, by syntax, more in Python. Okay, so this is what we saw, the capability, blah, blah, blah. So the example of binary smart contract, this is a simple Viper contract. So this was a network error. So can I do it here? Let me just here, and then again for this. So we have the Python-like syntax, limited features, no inline assembly, bounce and overflow checking, Okay, yeah, what we wrote. Blah, blah, blah. So here's a basic example of Viper contract stored three values. So we have a store data, then we set a public function or like an entry point or something like that. So we set x, and then it's an int of 128 bytes. Then get, and we are going to pass nothing, and we're going to return in this function. Okay. So can you make another example of can you make an example of a transaction in Viper? Something like sell chocolate, sell taco. Taco stand contract. Okay, let's consider a simple taco stand contract using Viper. This contract will allow users to buy tacos with Ether. So here's the basic setup. The owner of the taco stand can set the price up for a taco. Users can buy tacos by sending the right amount of Ether, and the owner can withdraw the funds from the contract. So the taco stand contract in Viper. So then we first declare the storage variables: owner, taco price of one taco in way, and then taco sold, the number of tacos sold. So then we have the constructor to set the owner of the contract, then init, then self owner. Okay, then allow the owner to set the price of a taco. Only owner. Okay. Okay, then we have buy tacos by sending Ether, then public payable. Okay, I think these are just decorators. By taco, calculate cost and ensure the sender paid enough. Web value, self taco price amount, insufficient payment, and if they pay too much, refund the difference. Yeah. So allow the owner to withdraw the funds from the taco sales, and modifier to restrict certain functions to only the owner. Only the owner can do. Okay, got it. So then let's try to copy and paste this here in Python. So let's try to create a new file called, how is this called? And how should this file be called? And in which format should I save it? Because I saw that there's a format called, I don't know, name of the file that by, yeah, the Viper contract. Okay, so extension for Viper source files for the TacoStan contract, you could name it something like TacoStan.by, then the subscript, Once you have the save file, you can compile it using the Viper compiler. If Viper is correctly installed, you can compile the contract using Viper Pakistan. This will output bytecode and Navi contract on Ethereum network. Awesome. Awesome. Cool, cool, cool. Then let's go here and create a new DACO contract.py. And let's see if we can have something like Viper extension. And so we have Viper here. Features, syntax highlighting, solid visual dark, compiler errors and fails. All right, so let's go here, refresh, reload this again, and try to do something. Try to see if we have enough time to create this contract of the taco contract. So, all right, so we already have the taco.py. Okay, so actually we have the syntax highlighting. Viper sessions compare file with the following errors, blah, 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 blah. Okay, so let's just click this until we know what is going on. And then compilation failed with the following error. Function is not the greater public contract take contract. Okay, so actually it is not public right now, it is external. Okay, so it is not public, it is external. So let's go here instead of pattern public, it should be external. Only owner. External. This is also quit this and external. And then we have the taco price, new price, way value. Not both lane is defined name way value. Did you mean as way value? As way value? Nope. Okay, so should it be something like an amount, an int? It's 28 bytes. I don't know. So what is way value? And this should be not public, right? It should be. Oh no, it actually is public. So it is an address. You need your int bool. Okay. So let me go into the documentation here. Share this up instead. So let's get started. So action parameter for so we have a public. So these are params. Then current state of an auction. Set the true bold end. We begin by declaring new variables, a few variables to keep track of our contract state. We initialize a global variable beneficiary by calling public and the data type address. Okay, so it's like C. It's something like C where we need to declare all of our functions at the top, or well, like variables that we're going to use at the top. Yeah, I think so. Yeah, got it. So let's start this from by 0 and call it something like Viper percent Viper contract. To declare some of our variables as an address and data type address. Do we have something like a searcher? Yeah, we have. So address Search results, no infra, nope. So we have types, I think. So we have Boolean, we have we have signed integer and bit. Okay, so then we have what else? We have unsigned integer, and unsigned integer we can store positive integers and must be okay. So then we have shift decimals. So we have decimals is a polytype store. Uh, Store a decimal fixed point value. Bu- 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 Okay, there you go. Address. So there's a type hold an Ethereum. The address type holds an Ethereum address. So an address type can hold an Ethereum address which equates to 20 bytes or 160 bit. Address literals must be written in a hexadecimal notation with leading must be checksummed. So syntax is follow address member where address is a type of address and member is one of the keywords. Okay. So let me search for Viper examples. Yeah. So I think this is a little bit more understandable. So let's try to confirm that. So hello world version specifies the compiler version of Viper. Then, so we have create a string variable that can store maximum 100. So we have a grid. There's going to be a public variable. There's going to be a string that stores. Okay, so it is actually hard um, type. So we have an external in itself grid is equal to hello world. So then we have data types, values. Some of the values in Viper are bool, init, qinit, decimals, address, bytes. Okay. So we have public, Okay, so we have bool, that is a boolean, and decimals, address. Okay. So we have a b that is going to be a boolean, e that is going to be an integer, u in the integer, then decimal is going to be a decimal, address is going to be an address, public address, okay? So b is equal to false, minus 1, 130 decimal. Then the address is the address in a hexadecimal, as we saw in the documentation. And then we have bytes of 32 and bytes and then strings. Okay, so data types references. So reference types are data types that are passed by us their reference pointer to where the actual data is stored. So how about struct? Yeah, it's actually C because we are using structs. Okay. Okay. Gotta give me just a minute so I can share this. Okay, so we have the struct, then we have a fixed list, size list. That is, then we start nums. That is the public unit of just 10 numbers, or is equal to 10. I don't know. No, actually, nums is an array of 10 elements. It's an array of 10 elements of type of integer of integer of 256. It is a public variable. So map. Okay, so these data types are maps. Okay. So are objects, maps, and arrays. Got it. And then person, we have, yeah, it's actually, yeah, I got it. Okay, so we have external, So this updates self nums. Okay, so then I can assume that the array is going to initialize with all zeros. Then we have self nums zeros equal to 123. Then copies self nums arrays in memory, does not modify reference variable. So then array is equal to self that nums. Then array of series 123. This update self my map. Message sender. Do we have something in message sender? Hmm. Okay. I'm going to assume that we have already something here. Message that sender is equal to 1. Self person that age is equal to this. Okay. I think I got it. So let me just read this again because I didn't kind of understand this. So my map is just a hash map which has an address and that no, it's a hash map that has a key value, well, an address value as a key and a u an integer of 260 bytes as a value. Okay. So then we said message sender. I can assume that message sender is an address is equal to 1 and do the same thing for other message sender or just self my map. So this updates self that person. Okay, and also we can have the dynamic arrays. Okay. Appending to array max 3 elements. Okay. Append. And then we have functions. Then we have external, pure, multiply. We initialize the parameters, then return x and y, then divide, return then do nothing, just pass them like Python, and then return. Okay. So add internal functions can only be called inside the contract, and add external functions can only be called from outside the contract. So we have internal functions that can be only called inside this contract. Is this add internal? Okay, yeah, got it, got it. This is like a private and a public, and if I call to the yeah, yeah, got it, got it. First, internal functions are the ones that we care to do stuff that is not accessible from other sides of the contract, and external functions are the ones that we can make a call. For example, make a bolt. Make a bolt can be an external function, but make I don't know, make bolts count or anything like that can be an internal function that is going to return something or do some stuff by internal so the user doesn't have to know what is going on, right? Okay, so external, exit function, and then average. Okay, then sum of the squares. Okay, got it. So both pure and build functions are read-only functions. They cannot write anything on the blockchain. Pure functions do not read any state or global variables, and build functions can read state variables, global variables, and call internal functions. Got it. Migrate state of pure. Okay. Then we have a constructor that says init is a special function that is executed only once when the contract is deployed. Then we have owner name created at expires at. Then def init has of owner message sender and name created at expires at. Okay, so it is basically just a constructor, and it's kind of normal construction like Python, but actually here we can pass types, strong type things as a string of just 10 bytes or 10 characters, and so on. So then we have private and public state variables. Okay, so public is a state variable, and owner public state, private state variable. Okay. Yeah. Then we have constants also. Oh, okay, this is cool. like for addresses, endpoints, and APIs and things like that. Hmm. Got it, got it. Okay, then we have immutable, and what is smart? What is immutable? Immutable variables are like constants is a value are assigned when the contract is deployed. So when you use immutable variables, you have a variable that needs to be set when the contract is deployed. For example, like setting contract over owner to message that sender. I'm still asking myself what is message that sender. So I think it is something like when I call that endpoint, like entry point or like that function is like the person or like kind of the transaction ID or anything like that. You have a variable that needs to be set when the contract is deployed. For example, like setting contract owner to message that sender, and this variable will never change after deployment. While declare variables as immutable, like constants, immutable variables save runtime gas. Okay, so then we have if. Uh, okay. Yeah, it's kind of the same like Python. Then force. Again, kind of the same as Python. Then errors. Use a certain race to check inputs and validate state. When an error occurs, it will have the entire function call and the changes. You will still need to pay gas for the failed transaction. Okay, then events. What is an event? Then event writes logs to the blockchain, commonly used by application to monitor blockchain state as a cheaper alternative to store data on blockchain without using state variables. Events can be efficiently searched by indexing their arguments. Up to three parameters can be indexed. So we have an event transfer, so enables a quick search of all transfer events where sender is a certain address. So we have sender index address, and then enables quick search of all transfer events where receiver is a certain address. So we have receiver amount. Then we have external. Then we have def transfers. So we have a receiver and amount, and then we log an event that is transferred. We send the message sender, the receiver, and the amount. Okay. Let me read again because I didn't understand. So events write logs to the blockchain, commonly used by applications to monitor blockchain state and as a cheaper alternative to store data on the blockchain without using variables. So events can be efficiently searched by indexing their arguments. Up to three parameters can be indexed. So we first declare an event called transfer, and this transfer has an indexed address. An indexed, what does it mean? I'm okay, it's just the arguments. Okay, so we said it's an argument that you're going to receive, and yeah, so we say that okay, so sender is an argument that you're going to receive, and is going to be as a type of address. And again, here, receiver is an argument that you're going to receive as a type address, and then amount you're going to receive. Well, the amount is something that is declared as um, a integer of 100 and I mean 256 bytes. So then we have playable. Okay, function declared with playable can receive either. Okay, so it's just for example deposit. Yeah, payable, not playable. Yeah, so okay, got it. So we have payable, then external, then deposit, lock deposit, and deposit is the event. Okay. Okay, got it. Okay, so Will David says, yeah, message sender is the address that calls external functions. Okay, thank you so much for explaining, Will. And oh my God, the time. So we have still 4 minutes left. So unfortunately, we didn't actually kind of, well, actually, we learned a lot of things. So we learned how to use Python for well, smart pipe for creating smart contracts. We didn't kind to get into deploying that smart contract into the blockchain of Tesos because I don't know, to be honest, I don't know what happened there. It was real weird. Also, we'll say that it was weird. Like it was already deployed to the blockchain, but it didn't show anything. And then we had then Will like told us that it would be a great option that to see something of Viper, and Viper looks real cool. It looks even more readable, for in my opinion, um, than the Smart Pi option or the Smart Pi alternative. And we'll kind of learn something like it is really similar to C++ or C because you need to declare hard type, declare all of your variables, and I kind of like it. It seems kind of cool. So I'm pretty sure that we're going to continue tomorrow with this because tomorrow I have to stream two parts of create crypto data visualization app with Python. So that would be something. But also we can do something else. Let me search. So we have also an introduction to Solidity tomorrow. No, on Sunday we have an introduction to Solidity, and then okay, yeah. So I think we can do some things tomorrow or this on Sunday. But thank you so much for being here. Unfortunately, we didn't kind of end up with anything, but we learned a lot. We learned, like I said, Viper, and we learned SmartPy, these two workshops. And yeah, thank you so much for being here. Thank you so much, Will, for helping me with all my doubts or all the times that I was really, really stuck with all the problems that I had. And thank you so much, Indigo, so much for being here. So have a nice week. I'll see you tomorrow and happy Lola Hack Week.